Hello! In this video I'm going to show you how to create and utilize pitch detection, also known as pitch estimation, by using the built-in Max MSP object retune. This patch takes the sound of my harmonica, or any sound I make really, and detects the pitch, triggering a major sixth chord based on that pitch through the internal MIDI synth of my computer. This is what we are going to create. So let's begin. The object we are going to work with today is called retune, or retune tilde, as it is an MSP object. Now, by default, this object is not going to do any pitch detection. The main function of retune is to, retune, to do pitch shift, to take an audio and tune it to specific set of pitches, creating a robot-like or an auto-tune-like result. However, that's not why we are using this object today, so I'm going to put in the attribute retune 0, turning off this retune function, and then typing at pitch detection 1, turning on the pitch detection function. What we have to do now is to work with a mono stream of audio, a single channel of audio. Retune does not work with stereo. We do not need to put in two channels of audio, two lines of audio stream. So I can simply type in EZDAC, audio to digital converter, so basically a microphone input, and I'm going to take the first channel, the first output of this object, and put it in retune. If I lock the patch and if I click on this microphone, now it is sending the audio data, the audio signal to retune. Since I have pitch detection on, the result of this pitch detection is going to come out of the second outlet, the detected frequency. However, if I try to create a floating point number box, for example, and try to connect it, it is simply not going to work. That is because the detected pitch is sent out as a signal, a continuous signal that represents the frequency of the detected pitch. So to visualize this, to work with this data, I need to create a number tilde, an object that acts as a signal monitor and also a constant generator. And I can put this signal right here, and now if I lock the patch and turn on the microphone again, as I'm talking, the number is kind of changing. Something is definitely happening. Okay, in fact, I can try to play my harmonica right now. Notice that if I play too fast or too quiet, the pitch detection does not work as intended. It does seem to work, however, if I am playing it loud enough and slow enough. Now, I want to take this information and convert it to a floating number. Luckily, I can do this by using the second outlet of number tilde, which will send out the signal value as a float number. So all I have to do is press F on my keyboard to create a floating point number box and connect it like this. Now watch what happens. It's the same number, but it has been converted to a floating point number, meaning we can work further with this. Of course, this is in frequencies right now, and I would like this to be in MIDI numbers. It is easier to work with MIDI notes, and then I don't have to worry if it's perfectly tuned or not. So I'm going to create a F to M. So frequency to MIDI note, MIDI number converter, and I'm going to connect it like this. Now this F to M is going to send out an integer number. That is going to be the MIDI number of the note, the pitch that is detected. One thing to note here is the -999. If there is nothing being detected, if it's too quiet or if retune is uncertain, it is going to send out -999 instead of 0 or instead of any number. So let's try to visualize this on a keyboard. I'm going to create a case slider. And I'm just going to plug this in like this. Since this is a MIDI number, since this is in MIDI notation, so to speak, it should automatically appear on the K slider. Fantastic. So I can simply just take these notes and do anything I want with them. Now they have turned from audio into MIDI notes, into MIDI numbers. So why don't I just try to play it out just to begin with? I will just do a simple make note. I'll just create a make note object. Let's make it fairly loud, and let's make it last pretty short, 250 milliseconds, meaning 4 times per second. I'm then going to connect the results to note out, which will send this data to the internal MIDI synth of my computer. Do you hear that? There's a low hum in the background. And it goes away if I turn off the microphone. This low hum is -999 being played as a MIDI note. Now, of course, there is no MIDI number or a MIDI note that can be represented as -999. So what K slider and all the MIDI objects in Max does is just playing the lowest possible note as a substitute. So if I'm giving -999 to K slider, it is going to send out the note 0, which is the lowest possible C in MIDI notation. And since it keeps playing, since this -999 is constantly sent to K slider, the note is triggered over and over and over and over again, creating this very low hum. Fixing this is very easy though. I just have to create a split object, which will look for a range of numbers, and then I have to put in the range of the numbers. So in this case, I'm receiving MIDI notes, which is going to be between 0 and 127. So a total of 128 numbers. And I'm just going to put this here. And now the numbers I'm going to get from the first outlet are going to be the numbers that are within these limits. The hum is already gone, but let me just play the harmonica just to see what happens. It does get it wrong sometimes, but it mostly works. And the cool thing is, it also tries to guess the pitch of my speech. So right now you're hearing my speech, the sound of my voice being translated into MIDI notation, into notes that are being played out by this patch. There is a small problem here, however. The notes keep repeating. If I'm holding a note, I'm just getting that note continuously played on this MIDI keyboard I have created. This happens because the signal data type, the signals in MSP, how signals in audio works in Max MSP, is constant. If the audio context is on, so if I have this button turned on, if the microphone is on, there will be a constant stream of data coming in here, and retune will be sending out a constant stream as the output. So even if I'm holding the same note, retune is detecting the same pitch over and over again, is turning that into MIDI notes, and that MIDI note is being sent to K slider. All I have to do to get rid of this is to eliminate the changes, and I can do this with the change object, which will filter out repetitions of a number. If I plug it here, now I should be able to get just one note if I'm holding the same note. If the same note is being detected by retune more than once, it's going to ignore the rest. Let's try it out. Great. Now there is only one thing to do, and that is to experiment. For example, something fun would be to trigger a chord instead of the exact note that is being played when a pitch is detected by retune. What I can do to make this happen is to create a +4. So I want this note to come in and I want to add 4 to that MIDI note, putting it 4 semitones higher, which becomes a major third, and also send this to make note. And then I'm going to do the same thing, but I'm going to add 7 to the original number, which is going to be a perfect fifth. And then I'm also going to add 9 to the original number, which means 9 semitones higher, which means a major sixth. So in total, playing this should generate a sixth chord. Let's also make this a bit longer. 250 milliseconds is pretty short. So I'm going to make this 1500 milliseconds, meaning 1.5 seconds. And lastly, I don't want a piano sound. I want a more paddy sound that I can use. So I'm going to create PGM out so I can send MIDI program messages to my internal synth. And I'm going to send the number 89, which should create a pad-like sound instead of a piano. Okay, and let's try it out like this. There are a lot of things you can do just with this idea. You can try to trigger different chords from different notes, change the chord type dynamically. Sky is your limit. And lastly, I want to talk about this last outlet of retune. There is some useful information that is being sent from this outlet. It sends out a list of the closest note, the closest pitch class that is being detected, and the deviation from that note in cents. And if I create a message box and if whoa, it is still detecting the sound of my voice. Let's turn this off for now. If I connect this to the second inlet of a message box, it is going to display the data coming from here in that message box. So if I trigger something now, I'm going to get a message like this: onset, an integer number, in this case -1, and a floating point number, in this case 0. So let's visualize this in a better way. I'm going to use the root object that is going to route an incoming message based on the input. So I'm going to type in onset as my selector, as my argument, and I'm going to put this message through that. Now, if retune sends out a message beginning with onset from this outlet, I'm going to get the rest of the message from this outlet. Then all I have to do is unpack this message, and I am unpacking first an integer number and then a floating point number, so that would be 0 dot. And lastly, I'm going to create 2 number boxes, one floating, one integer, to visualize this result. If there is nothing happening, right, if I'm getting -999 here, there is no pitch detection going on while the audio context is on, this is going to be -1. If I'm playing notes, however, I'm going to get a number between 0 and 11. 12 numbers total, representing the 12 chromatic pitches from C to B above that C. It is pretty much the pitch class which note is being detected. And a floating point number right next to it is a deviation, the difference from that pitch in cents. Using this, it is also possible to detect pitch classes to see which note is being played and maybe trigger different kinds of notes or different effects or even visual things from each unique note. You can find this patch in the description of the video below, and feel very welcome to play around with it, make your own variations, recreate it from scratch, add new modular things to it, make visuals happen, different chords happen, change scales based on which note is played. I hope this has been useful to you, and thank you for watching.